RC circuit. So aim of this experiment is to determine the time constant, of given RC circuit. So here in this experiment we are going to measure the time constant, okay. And then what is the apparatus required for this experiment? First one is breadboard and then capacitor, R and C. R is resistor and C is capacitor. Right? So resistor and capacitor we are going to use for this experiment. So the first apparatus is breadboard and the second one is capacitor. Its value is 1000 microfarad. This is micro, that is 10 power minus 6 farad, right? And then resistor 100 kilo ohm. Okay, so kilo means 10 power plus 3 ohm. 10 power plus 3 ohm, right? So resistor value is 100 kilo ohm and voltmeter, that is 0 to 20 volts, and the stop clock and then battery eliminator. So battery eliminator is nothing but DC power supply. So these are the apparatus required for this experiment, and this experiment will be performed in two modes. One is the charging mode and another one is the discharging mode. So first let me show the simple circuit for this, okay. So the simple circuit is nothing but like this: resistor and then capacitor. Resistor and capacitor will be connected like this. So this is R and C. So both are connected like this. This is the symbol for R and this is the symbol for C. Okay, so in between these two ends, okay, we are going to give the input. So now how can we give the input? Okay, so now V input. Okay, one end is connected to R and the positive end is connected to R and the negative end is connected to C, right? So here also the symbol is positive, negative. This is input, and then output we have to take, right? So output should be always parallel to C. So here I am going to take the output. This is V out. Okay, so here also positive and a negative. So input is nothing but input from where we are going to give battery eliminator, and output we are going to take from voltmeter. So here voltmeter, right? So this is what the simple connection, R and C, here input given, here output taken. So the same diagram I have drawn here. Now you see this is the battery eliminator. So I can able to write battery, right? And then this is the switch. Two terminals are there, no? This is switch, and this is R and this is C. Now you can compare these two diagrams. So this is resistor. What is the value of the resistor? I said 100 kilo ohm. Okay, and C is the capacitor. Okay, it is 1000 microfarad, right? And this is voltmeter. So here I am going to give the input voltage and here I am going to measure the output voltage. So this is what the circuit diagram. So now you will have the clear idea about the circuit diagram. So for charging mode, switch should be closed, okay, switch should be connected, and then we have to take down the values. And then for discharging mode, so how it should be performed? Discharging means the same diagram only. Okay, the switch, that means the input should be disclosed. Okay, now see here, the switch should not be connected, only this is the difference for discharging. So for charging means it should be closed, we have to perform the experiment. For discharging it should be removed and then we have to perform the experiment. So now let us go to the lab and do the experiment how we have to perform charging mode as well as discharging mode. Okay, so these are the tabular column required for this experiment. Already I said in two modes we will perform the experiment. One is charging mode and another one is the discharging mode, right? So charging mode, time versus voltage. We are going to find the time constant. So the variable is time and corresponding variable is voltage. Okay, here also time, voltage. So now the time value, that means for every 20 seconds we have to note down the voltage. Okay, so now let us go to the lab and do the experiment. Okay, after that we will do the calculation again.
Dear students, let us see the breadboard connections first. So first let us understand how the breadboard is constructed and how we have to give the connection on that. So let me show the breadboards. This is the breadboard we are going to give the connection for RC circuit, and the back side of the breadboard how it will be. So for that I have taken the another breadboard, and for understanding I have drawn the diagram also here. Okay, so first let us see this breadboard. So here the first part, here it is there, no, some dots are there. So here it is connected horizontally. So all the dots are connected horizontally here. Okay, and the top and the bottom of this breadboard we are having the horizontal connection. And the next set is center part. You see here some vertical dots we can able to see. So here 1 2 3 4 5, this 5 dots are connected vertically on the back sides. Now you can able to see. So the top and the bottom horizontal connection here, horizontal. Okay, and the center part is vertically connected. All the dots are vertically connected. This is what the difference. For our experiment we are going to concentrate only on this part, vertical part. Okay, so here top and bottom again we are having, center we have the gap. So how to give the connection? Now you see the 5 dots are there, no, the 5 dots are connected at the back side, but connected vertically. So now for example, for our experiment we have to give the connection of R and C. So how to give the connection? One end of R should go and then another end should go to the another hole. So now you choose any one line here. So one dot. Here I am going to insert the R. So here R, the other end is here. Okay, so R is connected now. The next setup we have to include the C in this. We have to include the C. This is R and this is C. So C should be connected to R. Already one end R is connected. The next dot I am going to connect the C. Or anywhere in this 5 dots you can connect the C. Why? Because in the back side it is connected vertically. So the next dot I am going to consider, and then here I am going to give the connection C. Okay, and then here I have connected like this. Okay, just here I have given the connection. So now R and C connection is done like this. Okay, the next setup, in this way we have to give the connection. The back side of this line are connected vertically. So you have to understand like this. So now let us go to the experiment. Okay, let us see the apparatus required for this experiment. Actually RC, that is resistor and capacitor, is required. So this is the resistor. Actually for this experiment we have taken 100 kilo ohm resistor. For resistor there is no polarity, that is positive or negative. Any direction we can give the connection. And then this is the capacitor. It is 100 microfarad capacitor. By seeing this you can identify one leg is long, another one is short. One is lengthy and another one is short one. Okay, so the lengthy one, that is the long one, is positive and the shorter one is negative. For capacitor this point you have to remember, this is positive, this is negative. And then this is the breadboard we need. Okay, and then this is the stop clock. For stop clock, this side. Okay, this switch is on off switch, so that it will start and stop. Okay, both will operate in the same button, and this is the reset button to make it 0 again. Okay, so this is what you have to remember in this stop clock. And this is the multimeter. So here we are going to use for the voltage. So now towards 20 you have to keep positive and a negative terminal for this. Right, and the next one is battery eliminator. This is the battery eliminator. Positive and a negative connection is required for this experiment. So these are the apparatus required for RC circuit. Next we will go to the circuit diagram and then we will give the connection. So now this is the circuit diagram required for this experiment. What is this? R and C are connected. That's it. R is connected to C, and in between R and C negative we have to give the input. Okay, power supply, and then output to be taken parallel to C. Okay, so this is what the connection. Let me explain how to give in the breadboard. Okay, so now take this breadboard. First R and C should be connected. So already we have discussed in the breadboard connection the same thing. Take this resistor, put it in one hole, okay, and then just bend and keep it in the other hole. So now R is connected. So next one is positive of C is connected to one end of R. Positive is the lengthy one, so keep it in the next hole and keep like this. Now this circuit has given input, that is R and C is connected, right? And the next step is input to be given here. So which is input? The battery eliminator is the input. So positive should go to, positive of input goes to R. So now I have given R here. So the positive terminal should go to the R here, the next dot. And then negative should go to C negative. So where is the C negative? Here I have given. So input has given in the circuit, and the next step is we have to take the output. So output is multimeter positive should go to capacitor positive, right? And then negative should go to capacitor negative. So we have to give the connection like this. After giving the connection, we have to switch on this equipment. Now you see, if you switch on, it is showing some values. So first what you have to do is, first reset the capacitor. The capacitor should be empty enough for charging. So first you touch both this knobs, okay, positive and negative should be touch each other, so that it will show 0. So previously it shown some value, but if you reset, if you touch this both, so that it will become 0. Now the capacitor is 0. Now we can start the charging process, right? So how to do the charging mode? Two modes we are going to perform. One is charging and another one is discharging. So charging mode, now listen carefully. This is the stop clock and this is the input power supply. So both should be on simultaneously. Okay, so power should be on and the stop clock also on. So for every 20 seconds you have to note down the value. So here the table is time versus voltage. Now you see how to take the values. Here the constants are, variables are time and voltage. So for every 20 seconds we have to note down the voltage. Okay, so for 0 seconds the voltage is 0. For 20 seconds, what is the voltage? We have to measure in this multimeter. So we have to note down the voltage correspondingly. How long we have to take the values means till we reach the maximum value in the voltage. Okay, up to that we have to continue our experiment. It will go beyond 300 also. Okay, no need to worry. You have to take the values up to the maximum value. Once it reaches the maximum value, there won't be any increment. So it will stop. That means it will reach the saturation condition. Till the saturation condition, we have to note down the values. Okay. So this is what charging part. So here, for example, we will get around 6. Okay, 6 volt. We have to go and we have to continue our experiments. Right. So once it is over, let me show the saturation value first. See now, the value is 6.90. So almost around 360 seconds we are getting the 6.19. So after that the variation is very less, it is not increasing much. So up to that we have to continue the charging experiment. The next step is we have to do the discharging. So discharging means it should be disconnected. The power supply should be disconnected from this experiment so that the capacitor should discharge. So the same experiments we have to do the same thing, time 0, 20, 40 like that. For every 20 seconds we have to note down the value. But we should start from the maximum value. Okay. So now you listen carefully. First I am resetting this stop clock. Okay, simultaneously switch off this power supply and switch on the stop clock. So now it starts getting down. Okay, it is going down. That means discharging takes place. For every 20 seconds, note down the discharging voltage. Now you see when it reaches 20, the value is 5.07. So like that you have to note down. First maximum value is 6.19 and then for 20 seconds 5.07. For 40 seconds what is the value? So like that we have to take down the values until it reaches 0 in the voltage. Until it reaches 0 in the voltage we have to continue the experiment. So this is what discharging mode. So discharging mode means we have to disconnect the battery eliminator and the stop clock should be switched on simultaneously. This is discharging, and for charging both should be switched on simultaneously. So charging means minimum 0 to maximum value of voltage we have to note down, and discharging means maximum to 0 we have to note down. So this is what the experiment. Remaining we will discuss in the calculation and the graph part.
After taking the values in the lab, we will observe like that. So first charging mode, the capacitor gets charging. So first voltage will be 0. Okay, so now time is 0, voltage is also 0. So when we take the values for every 20 seconds, finally we will reach that maximum value here. Okay, so the maximum value, after that there won't be any change. Okay, any change in the voltage. Even though if the time is increasing also, there won't be any change in the voltage value. So up to that we have to continue our experiment. So this is charging mode. And then when we come to the discharging mode, we will start from maximum value. We will start from maximum value, and then for every 20 seconds we have to note down the values up to 0, up to minimum value, right? So here in this case, charging minimum to maximum, and then discharging value will be maximum to minimum. So this is what we have taken in the lab. So now we have to go for the calculation part of this experiment. So how to do the calculation? So now let me explain calculation. So theoretically, time constant T is equal to R into C. Time constant T is equal to R into C. So already I mentioned R, how much we have taken is 100 kilo ohm, and then C is equal to 1000 microfarad. So 100 kilo ohm means 100 into 10 power 3 ohm. 10 power 3 ohm, and C is equal to 1000 micro means 10 power minus 6 farad. Okay, so now T is equal to, time constant is equal to, R value is 100 into 10 power 3 into 1000 into 10 power minus 6. If you multiply this, we will get 100 seconds. So as per theoretically, we have to get T is equal to 100 seconds. Then we have to draw the graph. So how to draw the graph? Okay, so theoretical value is 100 seconds. Now for charging mode, the variables are time and voltage. So now take this graph. This is the graph for you people. Okay, so first, once you take the graph, first thing is x-axis, and this one is y-axis, and then in x-axis, time, the time is the known variable for us. So time, its unit is second. Okay, and then here voltage, its unit is volt. First step, this you have to write. So here 0. So here first 20, 40, 60, 80, 100, 120. So keep on, it is going up to, actually we have taken the values up to 360. Just I have drawn like this. And then voltage value is, by seeing the graph you can understand, 1 point, 2 point, 3 point, 4 point, 5 point. So we can take the values like that only. See this. So here I can write scale, x-axis, 1 unit is equal to 20 second. This is very important. 20 second. Okay. 20 second. And then y-axis, 1 unit is equal to 1 voltage. Okay, 1 volt. So now here you can write 1, 2, 3, 4, 5, 6, 7, like that it is increasing. Actually our maximum voltage is 6.19. That's what I stopped up to here. So now if you draw the graph according to that, time is 0, voltage is 0. So now if you draw the graph will move like this. At 360 it reaches the saturation point. Okay, so the graph will go like this. Okay, after 360 it is becoming saturation, right? So now after drawing, that means if you plot 20, 40, 60, like that, if you plot, we will get graph like this. around 360 it become the maximum saturation value. So now the next step is, from this is the graph. So as per the value we drawn the graph, but from the graph how can we calculate the time constant? For that we have to follow one step. So what is the step? So now you see this is the saturation value. After this there is no change in the voltage. So first step, draw the straight line from the saturation line. Okay, for example it is 6.4. okay, 1 2 this is 3, 6.4. So now this is V maximum value. This point is V maximum. In your book it is mentioned V. Okay, go. So voltage across the capacitor V is equal to V naught into, for charging it is 0.63%. okay, 0.63. So V naught is nothing but V maximum into 0.63. So now if you check this V maximum, how much value? 6.4 into 0.63. So if you multiply both, we will get values around 4.12, like that. Okay, 4.12. So now this is the voltage across the capacitor, okay, during the time constant. Now you see where is 4.1 is there, this is 4.1, 4.1. So this value is nothing but V naught into 0.63. okay, from that draw the straight line to cut the graph. Okay, straight line to cut the graph. Take straight away here. Okay, we have to draw the straight line actually, straight line. So this is your time constant. Time constant. So time constant. So now time constant is equal to 100 second. Time constant is equal to 100 second. Theoretically also we have proven that time constant is equal to 100 seconds. So now our experiment is perfect enough. So now I will show theoretically how much value we got. See here, 100 seconds. Okay, so theoretically 100 as well as practically through graph also we are getting the same answer. Next we have to draw the discharging graph. So how to draw the discharging graph? The same procedure, everything will be same. Discharging mode. Okay, so time is the known variable for us. So time should be taken in the x-axis. So time, its unit should be mentioned in second. So first it should be written x-axis and then y-axis. So here we have taken voltage, its unit is volt. Okay, so we have to keep like this. The same scale, there is no change in the scale. So scale x-axis, 1 unit is equal to, we have taken 20 seconds, and then y-axis, 1 unit is equal to 1 volt. Okay, so here we will graduate 20, 40, 60, 80, 100, 120, and then keep on, it is going up to 360. Okay, and then here 1, 2, 3, 4, 5, 6, 7, like that. Okay, now after drawing this we have to plot the graph. So the maximum value starts from 6.19. So let me show the tabular column so that you will get an idea about it. See here, we start 0, 6.19, 6.19 maximum value. It is slowly, gradually decreases and reaches 0. Okay, so the same thing we have to do now. See here, starts from 6.19 and we will get graph like this. We will get graph like this. Okay, so now after plotting this graph we have to find out the time constant. So how to find the time constant? So voltage across the capacitor V is equal to V maximum into 0.37. So now this is the main thing we have to remember for discharging mode. Okay, 37% of the original charge, the maximum voltage should come down. So now here this is V maximum value, that is 6.1. So now 6.1 into 0.37 into 0.37. If you multiply, we will get the value around 2.2. Okay, 2.2. So now this is the voltage across the capacitor during the time constant. So where is 2.2? Here the 2.2 is there. So from this 2.2, draw the straight line to cut the graph. Okay. So this point is V into V maximum into 0.37. So we have to remember this point. So draw the straight line and take straight where the line meets the graph, from there take straight away here. Okay. So this is your time constant. This is your time constant. So how much time constant we are getting? 100. So time constant T is equal to 100 seconds. So now you see through discharging also same value, and then for charging, see here this is also 100 seconds, and then theoretically also 100 seconds. So in this way we have to find out the experiment and how to write the result. That is very important. So after completing everything, we have to write the result. So already in the aim we said to determine the time constant of the RC circuit. So now the time constant of the RC circuit by theoretically is equal to 100 seconds. Okay, and then in charging mode, in charging mode 100 seconds. Actually this is graphically we have to mention. This is theoretically. So graphically in charging mode, in discharging mode is equal to 100 seconds. So this is the way you have to write the result. The time constant of the RC circuit in charging mode 100 seconds, in discharging mode 100 seconds, theoretically also 100 seconds. So now we have completed the experiment. Please go through this. If you have any doubt, you can ask me in the comment box. Thank you.